Hey everyone. So in this video I'd like to talk about order of operations. So for most expressions, the order in which we perform the operations in that expression will change the result. And so if we want to start working with more complicated expressions, we'll actually need to agree upon the order in which we should perform the operations in that expression. This way, we'll get the same result, everyone will get the same result when we all look at the same expression. And so here let's go through each operation one at a time and then talk about what it looks like to start combining operations. So here, if we start with addition, well, the one thing I want to mention is that order of addition doesn't matter. Right, so if I have the expression 7 plus 3 plus 10, right, so I can compute 7 plus 3 first and then add on 10 later. And we write that using parentheses like this, right? 7 plus 3. Those parentheses are really showing that I'm talking about doing those first, doing that computation first, and then adding on 10 afterwards. Right, this gives me, well, 7 plus 3, if we do that first, like the parentheses suggest, and that gives us 10. And then we still have to add 10 on afterwards, and this gives us 20. But if we do the other addition operation here first, this one instead of this one, well, here we get 7 plus, and here I'm going to write 3 plus 10 in parentheses to say, hey, do this part of our expression first. So 3 plus 10 added together gives us 13. So this is 7 plus 13, which comes out to be, well, 20 again, like we expected. Right, so order of addition doesn't matter. It doesn't matter which of these two addition signs we perform first. And so to give this a name, this idea that these two orders of addition give you the same result, this is sometimes called the associative law. Of addition. And this name is not something I expect you to remember. I'm not going to ask you to remember, and you might not ever hear it again. But I just figured I would share that with you, just to give it a name. But the main point I want you to remember is that we can add in any order we want. Okay, so here, this is actually also the case for multiplication. So order of multiplication also doesn't matter. So let's say I have the expression 3 multiplied with 2 multiplied with 5. Right, so here I have two multiplications I can possibly do. I can either do 3 times 2 first and 2 times 5, and what I'm trying to tell you is that either one we take first will give us the same result. Right, so here if I take 3 times 2 and I do this first and then multiply by 5 afterwards, well, we get 6 times 5, and this gives us 30. On the other hand, if we take 3 times 2 times 5 and we do the 2 times 5 multiplication first, we get a slightly different next line in our computation process. This becomes 3 times 10, but actually this gives us the same result also, so this is 30. And so again, order in which we apply multiplication doesn't matter. And so here we call this the associative law of multiplication. We can either perform this multiplication first or this multiplication first, and we'll get the same result. So this is actually not the case with subtraction and division. Right, so if I take this expression, let's say 20 minus 8 minus 5, the order in which I perform the subtractions actually matters, right? So here, one way I can kind of imagine performing the subtraction that seems kind of reasonable is I can try and perform the first subtraction. I can say, hey, take 20 minus 8 and then subtract 5 afterwards. Well, 20 minus 8 gives us 12. And then we still have this subtraction by 5. And then 12 minus 5 is 7. Well, what if I did this the other way? Let's say I want to do the second subtraction. So I have 20 minus, and then let's say I did 8 minus 5 first. Right, well, here, I'll still have this 20, right? The parentheses say, do that part first. So 8 minus 5 gives us 3, and 20 minus 3 gives us 17. So in this case, we get different results based on how we ordered the subtraction, whether we did this subtraction first or this subtraction first. And so here, we saw that addition and multiplication were associative. There is no associative law for subtraction. The order in which we perform subtraction actually matters. And so I said the order in which we perform division actually matters too, right? So if I take 36 divided by 6 divided by 2, and so if we did the first division first, right, we get 36 divided by 6, if I wrap that in parentheses and then divide that by 2. Well, here 36 divided by 6 gives us 6, right? 6 goes into 36 6 times. And then we still have 6 divided by 2, and that gives us 3, right? 2 goes into 6 3 times. But, what if we interpreted the division the other way, where we divided, this one first? In other words, I put parentheses around the 6 and the 2. Well, here we have 36 divided by, 6 divided by 2, that's 3, right? And then here 36 divided by 3 is 12. And so here, this is just to illustrate that we get different results based on how we pick which operation to do first in this example. So if you're looking at expressions like these, 20 minus 8 minus 5, or 36 divided by 6 divided by 2, if you're looking at these expressions where the order in which we perform the operation matters, and there aren't any parentheses to guide you in which ones you should take first, the convention is as follows. So here, the convention is in expressions where there's just a bunch of addition and subtraction. So here I'm just going to say strings. In strings of addition and subtraction, there's no multiplication or division involved, just addition and subtraction, we perform the operations from left to right. Right, so if we go back to our above example here where we just have this long string of subtraction, we saw two options in which we can possibly compute this. Well, here what I'm trying to say is that this is the convention that we're going to take. When we just see addition and subtraction, we're just going to do those operations from left to right. Doesn't matter whether it's addition or subtraction, we just go from left to right. And this is actually what we do when we're just looking at multiplication and division as well, right? So here, similarly, multiplication and division is performed left to right. So here, if we look at our previous example, again, there are two possibilities we can interpret it, this expression, evaluating this expression, and what I'm trying to say is here, really the way that we would normally look at this expression is as if the parentheses were wrapped around the first two quantities, 36 and 6. Because here we perform multiplication and division from left to right. And again, there's no priority between multiplication and division. I'm just saying that multiplication and division will read them and perform them from left to right. And so here, if we look at another nice example like 12 minus 3 plus 4, we don't perform addition before subtraction. We just perform addition and subtraction from left to right. So here we will perform 12 minus 3 first to give us 9 plus 4. And then we'll add these together to get 13. And this would be very different if you were to take 3 plus 7 and then subtract that from 12. Right? So here we're doing these operations from left to right when we're just looking at addition and subtraction. And then similarly with multiplication and division, if I have something like 64 divided by 8 times 2, again, the multiplication doesn't come before division. Here we just do these two operations in order from left to right. Right, so 64 divided by 8 first gives us 8. And then here we still have multiplication by 2. And then 8 times 2 is 16. So in the last few examples, we were just looking at how we can order addition and subtraction together, and how we can order multiplication and division together. But what if we have expressions involving all of these operations, a mixture of these operations, like this one here, 2 plus 3 times 4? So like the previous cases, we can actually get different results based on how we compute this, right? So here, if we perform the 2 plus 3 first, and then multiply by 4 afterwards, this gives us 5 times 4 is 20. And if we perform the multiplication first, right, so 2 plus 3 times 4, well then here we get 2 plus 12, and this is 14. And again, we get different results, which we don't want, right? We don't want to look at one expression and have one group of people compute it one way and another group of people compute it a different way, right? So we all have to agree on something as to what this expression really is telling us to do. And so what we've agreed upon is that we will perform multiplication and division before addition and subtraction when we're looking at an expression. So here we perform multiplication and division before addition and subtraction in an expression. And so if we look back at this example, there are two cases in which we can compute this expression, this result, and here I'm saying that the valid one that we've all agreed upon doing is this one here on the right. Right? We perform the multiplication 3 times 4 before the addition, and so it's just adding on 2 afterwards to our product 3 times 4. And then what I want to say also is that here, the multiplication and division in an expression, it's still computed first before addition and subtraction, but it's computed from left to right between multiplication and the division operations. And then afterwards, after you perform multiplication and division from left to right, you'll perform addition and subtraction in your expression, and whatever addition and subtraction is there, you'll perform also from left to right. So let's evaluate this expression here, 2 plus 3 times 8 minus 6 plus 3. And I encourage you to pause the video and take the ideas we've discussed so far to evaluate this expression. So what we've said is, to evaluate an expression, which operations come first when we're talking about all the different operations. Well, here, multiplication and division come before addition and subtraction, and so the first thing we ought to do here is this operation here. This should be number 1. Right, so here, this expression, it's the same as 2 plus 3 times 8, and 3 times 8, that's 24. And then we have minus 6 and plus 3. And then now we just have addition and subtraction. Right, so from here, addition and subtraction are ordered just from left to right. And so we don't have to think too much about this. 2 plus 24 is what we do first, and that gives us 26, but we still have minus 6 and plus 3, and we still go from left to right, giving us 26 minus 6 is 20, and we still have the plus 3, and then finally we get 23 out at the end of the day. So here let's evaluate another example. I'll write it just below. It's 10 divided by 5 plus 20 minus 4 times 5. So here, let's go through this example, but maybe before we do it together, let me ask you to pause the video and give this example a try yourself first. So here, what we want to do is we want to perform the multiplication and the division before the addition and the subtraction, and we want to do this multiplication and division from left to right. So technically, we'll do this division first here, and then this multiplication second. Right, so here, this is equal to 10 divided by 5 gives us 2, plus 20 minus 4 times 5. And then here the next step is 2 plus 20 minus, so 4 times 5 is the next step, and that gives us 20. And then we perform the addition and subtraction from left to right. So this gives us 22 minus 20, which is 20, no, it's just 2 at the end of the day. So this is our final result, just 2. So if you're ever creating an expression and you want to perform addition or subtraction first in that expression, we can use parentheses to explicitly state this. Right, so let's say I have 5 minus 2 times 7. Normally 2 times 7 would occur before the subtraction, right? So we would get 14, and then we'd have to take that away from 5. But if we wanted to state that the subtraction should come first, we can use parentheses to do this, right? So just like we said earlier, when parentheses sort of tell us what we should look to first, what we should compute first. And so if I wrap the 5 minus 2 in parentheses, that tells us this subtraction comes before the multiplication, just because it's wrapped in parentheses. And so here, this is one thing I'd really like to point out is that, and explicitly state, is that we should perform any operations inside parentheses first. Right, so let's say I have the expression 2 plus 5, and then beside it, parentheses, 7 minus 3. And so, I look at this expression, and there are many different operations going on, right? There's this addition here, there's a subtraction here, there's no operation here, that's describing multiplication, right? Between that 5 and the parentheses, that's telling us multiplication, because there's no operation between them. And there's these parentheses here. And what we're saying is that if we want to compute this expression validly, what we should do is we should compute these parentheses first, what's going on inside the parentheses. And so this gives us 2 plus 5 times, this is 7 minus 3 is 4. And so now all of the operations inside the parentheses have been performed. And so now we're just left with 2 plus 5, and then here this is saying multiplication, because there's no operation between these two quantities. And so that's the next thing we're going to perform, right? 2 plus 5 times 4, we do the multiplication first over the addition. And so the next step here is to say, we've got 2 plus 20, and this gives us 22. And so that's the final result here. And one thing I want to emphasize here is, this 2 plus 5, this is definitely not the first thing you do. Right? This is not first. That 2 plus 5 there, adding that is not valid. It will give you a very different result, because it's like saying to perform this addition before this multiplication, which we know is not the agreed upon sequence of operations to perform. So the next example I'd like to look at is for us to evaluate this next expression, 19 minus, and then in parentheses, 7 plus 4 times, in parentheses, 5 minus 3. So, pause the video, try this example out yourself, see if you run into any issues, and then we can go over this together. So here, how should we start this expression, start evaluating this expression? Well, I see some parentheses here, so, the first thing I should do is I should look at these parentheses and try and evaluate that expression. And so, in trying to evaluate this expression here underlined in pink, I see again, I should still be applying order of operations. I see even more parentheses, so I should really go to these parentheses first. And so this tells me, I still have 19, I still have my parentheses here, 7 plus 4, but what I should really compute is this innermost parentheses at 5 minus 3, and that gives us 2. Right, so that's the result from those parentheses. And then here, there's no operation between this 4 and this 2, so this is telling us that these are multiplied together. And so here, we're still looking at evaluating this set of parentheses now. And to do so, we perform our order of operations. We have addition, we have multiplication there. And so all that tells us to do is perform the multiplication first, which is 4 times 2 is 8. And so we still aren't finished computing what's inside the parentheses here, but we're getting there. Here we have 19 still outside of the parentheses, and then 7 plus 8 is 15, and that's being subtracted from 19, which is going to give us 4. So here, this is an example where there's multiple sets of parentheses, and really you just kind of work your way from the innermost parentheses out. Also another thing I want to mention is in this example, if you're familiar with the distributive law, that's also another valid way to try and work through this example. We haven't talked about the distributive law, so I haven't brought it up. But this is something we will cover in the future, and gives us a little bit of flexibility with evaluating expressions. But I'm not going to talk about that now. So, like parentheses, fraction bars also group different parts of an expression together. Right, so here if I have 24 plus 6 in the numerator of the fraction, and 12 plus 6 in the denominator of this fraction, here I have addition in the numerator, I have addition in the denominator, and that fraction bar is giving us some form of division, right? And we know normally we would take division and apply that before any addition or subtraction. But here this fraction bar is kind of naturally grouping some parts of the expression together. And really when you look at this fraction bar, you want to look at this numerator first altogether, as well as this denominator altogether grouped up before you do the division that fraction bar states. So this fraction bar really naturally splits up our expression into two groups, the numerator and the denominator. And you want to look at those separately. And so here, looking at the numerator first, we get 24 plus 6, that's 30. And then the denominator, when we group that together, 12 plus 6 gives us 18. And then if I really want to take this expression, or this quantity, and make it as simple as possible, oftentimes we like to reduce our fractions. And so here, this fraction, its numerator and its denominator share a common factor, right? They're both divisible by a few different numbers, the largest of which is the number 6. And so dividing 6 from the top and bottom of this fraction leaves us with an equivalent fraction, 5 over 3. These represent the same part of a whole. And so here, that's our result. That's the same value as the original fraction that we've got here. But one thing I want to mention is that if we look at this expression, sometimes I find that people want to reduce this fraction a little early in a way that's not valid, and I want to kind of highlight this now. So here we reduced this fraction, 30 divided by 18, we divided the top and the bottom of this fraction by 6 to reduce this. And you might have looked earlier at this fraction and saw that, well, here there's this 24 and this 12, and I know 12 goes into 24 2 times. What if I tried to reduce this fraction that way? So what if I had that same fraction, 24 plus 6 over 12 plus 6, and I tried to reduce this 12 and 24 by writing it as, well, 12 goes into 24 2 times, right? So I might write this as 2 plus 6 over 1 plus 6. And then we would get 2 plus 6 is 8 over 1 plus 6 is 7. Here we ended up with a different result. So actually here, what we tried to do is not valid. So normally we can only reduce by dividing the same number to the entire numerator and the entire denominator. And really that's simplest if we just completely compute or evaluate the numerator and completely evaluate the denominator and then try to reduce afterwards, right? So here it was very clear how to reduce up here. And really I'm just trying to say that trying to reduce a fraction when it's got a bunch of different operations in the numerator and the denominator, it's not exactly so clear how to do, and this is not a valid way to do it. Try and perform those operations first, simplify the numerator, simplify the denominator, and then maybe reduce afterwards. So, there are different ways to reduce a fraction a little bit early before you perform all these operations, but this is a topic of a later class when you deal with something called factoring. But in general, I guess the main point I want to make here is that the fraction bar really groups the numerator together, and then it groups the denominator together and separates these two things. And so really the fraction bar is a lot like wrapping the numerator in parentheses and the denominator in parentheses. Right, so here, if you wanted to write this kind of fraction bar in a calculator, sometimes calculators don't really read these kind of fractions all that well. You might write this as 24 plus 6 grouped together divided by 12 plus 6 grouped together. You would need to use parentheses to really emphasize the same grouping that this fraction bar does. But really, this is the way you should look at a fraction bar, is that it groups the numerator together, it groups the denominator together. So the last idea I'd like to point out before we wrap up this video is that order of operations applies to variables too. And so if I have the expression 5 plus 2x, and again this is saying the same thing as 5 plus 2 times x, when we don't have that operation between them, that's multiplication. So x, it's a letter, it's there to represent a variable, but it's also representing some unknown number. Right? And so here, order of operations also applies to this variable here too that's representing a number. And so when we look at this expression, and we have the addition and the multiplication, order of operations tells us to do that multiplication first. Right? Multiply 2 and this unknown number x before we add on 5. And so here maybe I'll just write all that down to really emphasize. So first off, right, x, it's a number. I know it's a letter here, but it's really there to represent some unknown number. And here order of operations tells us to first, before anything else, multiply 2 and x. Right, we do multiplication before addition, so multiply 2 and x before we add that on to 5. And then afterwards, right, then add on 5. And here, I just want to emphasize that we can't rewrite this expression in any different way. Even though there's that addition here, we really shouldn't do that 5 plus 2, right? Here, this expression, this is not the same thing. It's not conveying the same idea. 5 plus 2x is not the same thing as 7 plus x, right? If we try to add that 5 plus 2 together, that's really the wrong thing to do, and it's going to give us the wrong result, just like we showed before, right? So here, maybe just to compare, like earlier, when we looked at 2 plus 3 times 4, right, we got a different result from adding on 2 to 3 times 4. Right, this gave us 2 plus 12, which was 14. We got a different result if we tried to apply the addition first, right? 2 plus 3 times 4. Right? This was equal to 5 times 4, which is 20. We got different results. And here, if we do the addition before the multiplication, and we try and call this 7x, right, 5 plus 2 times x, this would be a very different quantity than what we had to start with. And so although we don't know what the value of x is, that multiplication comes first, and that addition we can't, I know it's what we would do afterwards, but that doesn't mean that we would add it on with 2. That's not the same thing. And so all I'm trying to say here is that actually we can't really do much with this expression as is, unless we know the value of x, right? So here, sometimes there's just not more to do with an expression, even though there's an operation there like 5 plus 2 times x. So here, we can't perform any more operations here without knowing x. And so here, maybe just to really showcase this, And so let's evaluate 5 plus 2x at x is equal to 3. All right, so what do we get from this expression here? Well, we have 5 plus 2. We're replacing x with 3. And so this gives us 5 plus, right, we do multiplication first. This is 6. Added on to 5, this gives us 11. All right, what if we tried to evaluate now 7x at x is equal to 3? Right, this is just to emphasize that these are not the same thing. These expressions don't represent the same number. Right, so here if I take, and I shouldn't say equals here, if I take 7x and I replace x with 3, well, here we end up with 21. Again, just to emphasize, these are not the same value. They don't represent the same quantity, and so our expressions couldn't have represented the same quantity to begin with. Right, so all I'm trying to say here is that we can't really perform this addition until after we've performed the multiplication. And so the last examples I want to go over to cover this last idea a little bit more thoroughly is that here I want to take some phrases and rewrite them as algebraic expressions, and then I want to evaluate these different expressions at x is equal to 2 and y is equal to 6. So here this is a nice, these two examples are nice practice problems, so I really encourage you to try these first, and then here we can go over them together. So the first example says 3 times the sum of x and y. And so here this is the first example. We're taking 3 times the sum of x and y. And we want to write this as an algebraic expression. So the first part of the statement says 3 times the sum. So 3 times something, right? We're multiplying 3 with something. And so what are we multiplying 3 with? We're multiplying 3 with the sum of x and y. And so the sum is referring to addition, right? We're going to add some quantities together. But what two quantities are we going to add together? Well, here it's saying the sum of x and y. These are the two things we're adding together. You know, this and this. So here we're going to add x and y together. But here it's saying 3 times the sum. The sum is the result of the addition. So 3 times this addition, x plus y. So I should add that x plus y in parentheses to say, okay, I'm going to sum these things, and that's what I'm going to take 3 times, 3 multiplied with. So here that's our first expression. And here maybe let's do our second expression as well before we evaluate them. So here our second expression is the sum of 3x and y. So again here this word sum, it's telling us to add 2 things. And what are we adding? Well, we're adding this and this. So we're adding 3x plus y. And so here, you know, a lot of the same words are used in these two expressions, but we actually get, you know, quite different results. So one is saying 3 multiply with some group, and then the other example is saying 3 times something and then add it on with something else. So, you know, they're very similar sounding expressions, but they end up with, or similar sounding phrases, but they end up with quite different expressions. Okay, so now let's evaluate these expressions at x is equal to 2 and y is equal to 6. So here I'm going to take 3 times, well here we're replacing x with 2 and we're replacing y with 6. So this gives us 3 times 2 plus 6. And so to evaluate this, we do the parentheses first. Right? So 3 times 2 plus 6 is 8, and this comes out with the result 24. So in the next example, we take 3 multiplied with x, which we're calling 2, right? We're saying x is 2. Then we're adding this on with y, which we're letting be 6. We're evaluating at y is equal to 6. So this is 3 times 2 is 6, right? We're performing the multiplication here before the addition here. And so we're adding this on with 6, and then 6 plus 6, that's 12.